area between curves, the first thing we need to know is the bounds of our integrals, because for different bounds we can see that the red function is above the green, and for different bounds the green function is above the red. So the first thing we need to do is calculate these intersection points so that we can know what our bounds of integration are. And to do that, we make f of x equal to g of x, and then solve this. Now, if this is a graphing calculator problem, we can just solve this on a graphing calculator. In this case here, this can be solved algebraically. So I'm going to make these equations equal to each other, and then solve this equation. So I end up with x cubed. So this is going to end up being minus 1x squared minus 2x equals 0. And factoring and solving this, I end up with x minus 2, x plus 1 equals 0. So my solutions are going to be at 0, 2, and negative 1. So this intersection here is at negative 1. There's 0, and that's going to be at x equals 2. So this establishes my bounds of integration. To find area, I need height times width. To get the height, if I take a look at this region in here, this height, to get the rectangular areas, which I'm going to sum up, I need to find the difference in those two lines. So I need to subtract. And I'm going to subtract the upper function from the lower function to make this difference positive. Okay, because I want to have positive area. So when I do that part, I'm going to use the green minus the red. For this section in here, I'm going to use red minus green. Okay, so I'm going to set this up. So for this green area, which I'm going to shade in green, this area in here, the integral is going to look like this. The integral from negative 1 to 0, so those are my bounds that I solve for. And it's going to be the red function, which is f of x, minus the green function, which is g of x. And I'm going to multiply that by dx. Okay, it's going to multiply that by the width. And then I need to find out the red area here. And find out the red area, first of all, by working out the bounds from 0 to 2. And it's going to be the upper function, in this case it's going to be g, minus lower function, f. And then I'm going to multiply that by dx. So that difference is going to give me the height, and I multiply it by dx, it gives me the rectangular area. So then I'm going to subtract these. So the integral here is going to be from negative 1 to 0. It's going to be the f function, which is a cubic function, x cubed minus 2x squared, minus the g function, so it's going to be minus negative x squared plus 2x, and that's going to be times by dx. So I'm going to simplify this from negative 1 to 0, x cubed minus, okay, it's going to be minus 2 plus 1, so minus 1x squared, and minus 2x. And I'm going to do the red area. It's going to be the opposite. So it's going to be the integral from 0 to 2. It's going to be negative x squared plus 2x minus x cubed minus x squared. And times that by dx. Okay, and when I do the opposite subtraction, what ends up happening, so this is going to be 2x here. So when I do the opposite subtraction, I'm just going to get the same value, but opposite sign. So it's going to be from 0 to 2, and I'm going to end up with negative x cubed plus x squared maybe plus x squared plus 2x. That's going to be times by dx. Okay, so then I anti-differentiate this and work out the integral. That's going to give me the area. So this ends up being x4 over 4 minus x cubed over 3 minus x squared. And I'm going to integrate that from -1 to 0. When I substitute that in, I end up with 0 minus, this is going to be 1 over 4 plus 1 over 3 minus 1. And so this becomes 7 over 12 minus 1 is positive. Becomes negative 5 over 12, so minus a negative is going to be positive 5 over 12. Okay, and then I'll work out the red area. It's the same integral. It's going to be x4 over 4 minus x cubed over 3 minus x squared. This integral is going to be from 0 to 2. So when I plug in the values, I end up with, this will be 2 to the power 4, which is 16 over 4. That works out to be 4 minus 8 over 3. So this is going to be plus 8 over 3. This will be plus, and this is going to be minus. Sorry, get my signs correct here. So it's going to be minus 16 over 4 plus 8 over 3, and then substituting that in, that becomes plus 4 minus 0. Okay, the plus 4 minus 4 cancels out. These cancel out. So we end up with plus 8 over 3. So plus 8 over 3. Add those together. I'm going to end up with, this is going to be 32 over 12 plus 5 over 12. This works out to be 37 over 12 units squared.